16.3. In this part, I want to give you some example. Yeah. Average rate example. Yeah. So it is a simple concept, but when we need to calculate the average rate, many times the students cannot do it right. So I want to use this example to explain this concept, try to help you get good understanding of this concept. All right, so first, let's look at the question. Our example number 1. Yeah. If the transistor density of a chip is increased with 30% annual increasing rate for 4 years, 4 consecutive years, the first part of the period, and then with 40% increasing rate for another 4 years period. Yeah. So total 8-year period. Yeah. What is the average increasing rate during the 8-year period? It looks a simple question, right? A simple question related to the average increasing rate, this concept. Yeah. But I use this simple example to show you what is the correct way to calculate this average increasing rate. Yeah. So let's start our understanding of average rate. Yeah. When we talk about the average rate, many students, they tend to do something in this way. So let's take a look if it is correct or not. They tend to use the usual average formula like this, a plus b divided by 2. Yeah. So here they may like to do this way. 30% plus 40% divided by 2 equals 35%. Think about this way. For yourself, do you think this is the correct way or not? Think about this. Yeah, because this is the obvious way many of you, I estimate probably more than 1/2 of you will do in this way. Here the answer is, it is incorrect. This way, it is incorrect. The formula is incorrect. The answer pretty close to the real correct answer, slightly different, but this formula is incorrect. Here I want to explain. If you do not know the reason, so I want to explain to you. All right. Here, first, when we talk about the average, do you know there are several different meanings of average? Right? Several different meanings of average. Okay, so let me review a little bit. First, there is one average called arithmetic mean. Mean here means average. Okay, mean. Yeah, in statistics, it's average. But here, arithmetic mean of 2 numbers, that's this one. But there are some other means that could be defined. Yeah. Another is geometric mean. Geometric mean. How about this? Have you heard of this? Let's still use A and B. Geometric mean of A and B, square root of A times B. Have you heard of that? Yeah. So geometric mean. Why? Because given fixed area of a rectangle, A and B. All right. The area is fixed. You cannot change the area, but you can change the dimension of the rectangle. Now you want to average the dimension, make the dimension equal square x, but with the same area. Same area. X squared equals AB, so x equals root A times B. So we call it geometric mean because you use this geometry background. So geometric mean. Have you heard of that? Yep. So that's another mean, another average, right? Yeah. And the third one, another average, harmonic mean. Have you heard of that? Harmonic. Have you heard of that? Harmonic mean. 1 over A reciprocal plus B reciprocal. Harmonic mean. Have you heard of that? Yeah. So that's another special type of mean. Although the most popular one is arithmetic mean. Geometric mean, most people are not familiar with geometric mean. Okay? Yeah. Harmonic mean, only very small percent people, less than 1% knows this name, harmonic mean. Yeah, this one. Okay? Yeah. So for so many different means, which one we should use, right? Yeah. Although most of the time we use arithmetic mean, but there is some special situation. Special situations. You should use other different average. Yeah. So here we look at that part. Yeah. All right. So here I give you the background. Yeah. Now we want to get the right understanding, the fundamental way for average. If you want to get the right way to calculate the average, you should use the fundamental understanding. So what's that? That's spread increasing amount evenly over the whole period. The fundamental way. Yeah. So you consider the whole period, the change of the whole period, right? Yeah. So you change. So here we consider change in one period of time. So any number of years, period. The change increasing, right, from beginning to end. All right. But here the change, I should draw the change in a curve way, right? Yeah, because the change can vary, yeah, up and down, vary. All right. So now we want to have a change. We assume we get the same change, but we use a uniform way to do the change. Uniform way to do the change. Okay? Yeah. So that's the evenly, yeah. Spread the amount, total increasing amount evenly in that period. So this is the fundamental understanding. If you start with this understanding, you will be very likely to get a correct answer. For this example, we will use this way understanding. Yeah. All right. Next, before we work on the correct answer, I want to point out why our previous answer is incorrect. The previous answer, A plus B divided by 2, 35%, that's incorrect. I want to explain that, because many of you may wonder, yeah, what's wrong with it? Yeah. All right, so let me use a simple example to explain that. Yeah. In my example, it is very simple. Most people likely to use this formula, but it is incorrect. I just want to make that point. Incorrect. All right. Now, we want to travel from A point to B point, all right? Because there is a slope here, right? Yeah. Suppose we ride bicycle, okay? So we ride bicycle. Bicycle, okay? Yeah. Then from A to B and from B to A, the speed should be different, right? Yeah. When you riding upward, it is slower, right? Downward, faster. So that's our everyday life experience. Here, let me assume from A to B, the speed is 3 miles per hour. Okay? 3 miles per hour, the speed. The downward, the speed is 4 miles per hour. All right. Now, I want to ask you, the round trip from A to B, then from B back to A, what is the average speed? What is the average speed? Pretty simple question, right? Yeah. Based on our everyday life experience, how many of you feel the average speed is 4 plus 3 divided by 2 equals 3.5? How many of you will give me the answer the first time if you do not watch this video before? Okay, so I believe probably 80% of you will give me this answer. It's incorrect. How to get the correct answer? We need to go back to our fundamental. The previous slide, the fundamental of the average. We just use that, the fundamental. All right. Now the whole period, this whole period from A to B and B to A, right? Yeah. So that's the whole period. When you start travel from A to B, then from B to A. So that's the whole period. Okay? What is the total distance of that whole period? Here, let me use capital L represent the length of the distance between A and B. So the total distance from A to B, you have L, B to A, you also have L. So the total distance is 2L. What is the total time from A to B and B to A? A to B and B to A. Total time. Total distance divided by total time. Is that the average speed? Right? Yeah. So the average speed, V average equals the total distance over total time. All right. Total time equals 2 parts. From A to B, how much time do you need? How many hours do you need from A to B? Yeah. The distance L divided by the speed 3, right? From A to B. How much time do you need from B back to A? Total distance L divided by 4. How about that? Okay, all right. Yeah. So now the total time L over 3 plus L over 4. Okay, all right. L, we do cancellation. We don't know how large is L. Can we do cancellation? So we will have 2 over 1/3 plus 1/4. Here you can see this actually is the harmonic mean. Of 3 and 4. Yeah. In my previous harmonic mean, I forgot I forgot that too. Yeah. The harmonic mean between A and B. Yeah. Harmonic mean 2 over 1 over A plus 1 over B. Yeah. The previous I used 1 over. Yeah. Actually, it's 2. Yeah. Because here we see that 2, right? Yeah. So this corresponds to the harmonic mean here. So here you can see in this special situation, we should use the harmonic mean. Okay? Yeah, let's calculate what is the harmonic mean. 2 over 1/3, 12, 4 over 12, 3 over 12, right? So 2, 7 over 12, reciprocal 24 over 7. Okay? Yeah. 3 and 3/7. How about that? The mixed fraction 3 and 3/7. It's different from 3.5, right? Different from 3.5. See? Slightly different, but still different. The formula is different. So from this example, you can see you should be very careful when you calculate average rate. You need to go back to the fundamental, right? The original understanding, right? The total distance over total time. Total change during the period, then try to assume you have a constant rate in that period. Then you calculate that constant rate. So that's the average rate. Now, with this understanding, now we are ready to solve this example 1. Yeah. So let's look at the solution. Yeah. It's pretty simple. Yeah. Overall increasing amount, we know that. We can calculate that easily. Yeah. So let me draw this line. There are 8-year period. So I draw 8 line segments. Yeah. The first 4 segments, 30% increasing rate each year. Next 4 years, 40% increasing rate 4 years. Yeah. So we calculated increasing amount, using that, composite, right? So that formula, 1 plus 30% raised to the 4th power. Next one, 1 plus 40% to the 4th power. Total increasing amount multiplied together, so we get this amount. Now we imagine during this 8-year period, we have a even fixed increasing rate R. This increasing rate R is applied every year for that 8 consecutive years in this way. So what is the total amount during that 8-year span? Apply our standard formula, 1 plus R to the 8th. Okay, and these two expressions should be the same, right? We represent the same thing in 2 different ways so that we can set up an equation. So next, let us set up the equation and solve it. This is the equation. Only one variable, so we can solve it easily. The first time we simplify it, we can take 4th root both sides. So we get 1 plus R squared equals product of 2 numbers. So second, solve this equation for R. Easy, take square root, minus 1. So R equals root of 1.3 times 1.4. Okay. Here you can see geometric mean, right? Geometric mean of 1.3, 1.4. Yeah. And at the end, minus the base number 1. 1 is the base number. Okay, so here you can see, here we have a chance to use the geometric mean. In the example I give you before, harmonic mean. See, we have chances to use different means. So the answer approximately 34.9%, although very close to 35%, but the formula is different. The formula is not a plus b divided by 2. It's not that. Okay? It's not that. Yeah. All right. So this is the right way to calculate the average rate. Yeah. So I hope I use this simple example to help you understand average rate better. And then later, when we have many questions related to the average increasing rate, you can find the correct way to do it. Okay. All right, so that's this video for our first example. All right, so let me stop here. Yeah.